while soil health management systems that include reduced disturbance tillage, the use of cover crops, and valuing the preservation of soil surface residues are common in many parts of the cotton belt, including in Tennessee, where over 80% of cotton has been produced for decades using no-tillage and high-residue practices. Cotton production in California has historically relied on clean seedbed preparation and high-disturbance tillage practices for its success over the years. Interviews with early California cotton pioneers reveal that cotton planting and general soil seedbed preparation techniques have changed very little with respect to soil health management principles since the crop was introduced in the San Joaquin Valley in the early 20th century. There were a couple of notable exceptions to the dominant production paradigms that were developed during those early days, including the reduced tillage implement called the shredder bedder that was created by visionary inventor Al Ruzi in Bakersfield, California in 1954, that would go through a field of harvested cotton and in one pass, using minimum shallow soil tillage, completely reform planting beds for the next crop. Development of this machine was a little-known achievement, yet it was one of the most remarkable and innovative feats ever accomplished in California agriculture. Wider use of such reduced disturbance approaches did not catch on until several decades later. In the 1960s and 70s, Lyle Carter, an agricultural engineer with the USDA Agricultural Research Service Cotton Research Station in Shafter, California, was also at work designing and evaluating approaches such as wide spanner machines for cotton production that resulted in less disturbance and compaction of the soil. Although Carter points out that wide tractive frames had been proposed over 100 years earlier, his own research with controlled traffic farming systems for cotton, in which traffic zones were separated from plant growth zones, led to reduced total energy use, soil compaction, and production costs, as well as improved timeliness of operations and environmental conditions, with no loss of yields. The development of soil health management systems for California cotton then accelerated in the late 1990s and early 2000s with the introduction of several so-called minimum tillage machines, such as the Incorporator, which was later become the Optimizer, manufactured by One Pass Tillage Company, and the Eliminator, manufactured by Wilcox Agri-Products. These implements allowed for reduced pass tillage, but they still left a large volume of soil disturbed, as is done with conventional approaches. In 1999, landmark work on soil health management systems for California cotton was started at the University of California at the Agricultural Experiment Station in Five Points, in a national research initiative project that has been in place at that site ever since. Originally designed as a study of the potential for reduced disturbance tillage to reduce particulate matter or dust emissions from production fields, the project was the first effort to integrate the widely recognized key principles of soil health that include reduced disturbance, surface residue preservation, deliberate carbon inputs via cover crops, and the goal of preserving biodiversity in California cotton production systems. During its first 12 years, the study used a straight cotton-tomato rotation that was common in the San Joaquin Valley at that time. The first 3 years of the study saw lower lint yields in the reduced disturbance systems, due largely to an inability early on to get adequate crop stands with the John Deere 1730 no-till planter that was used. Also, because raised beds were not used, as is customarily done with conventional cotton planting systems that plant into moisture and pull a cap of soil over the shallowly placed cotton seed to protect it from drying, the reduced disturbance systems were essentially planted flat with as little movement or disturbance of surface residues as possible, and considerable learning and equipment adjustment were needed in order to get adequate plant populations in the field. However, once these planting techniques were mastered, similarly yields between the standard cotton systems and the no-till systems were achieved. To date, when cover crops are used in California cotton systems as a soil health management practice, they tend to be first shredded and then incorporated into the soil with an implement such as a disc or some sort of reduced pass tillage implement, such as a Wilcox eliminator or a one-pass tillage optimizer. These implements mix cover crop biomass completely into the surface 8 or so inches of soil, and then leave clean surface seedbed conditions for cotton planting. Cotton seeding options for planting directly into cover crop or prior crop residues include either the use of specially designed and available residue managers that can be mounted ahead of planter row units, or the use of strip tillage, in which a band of about 1/3 of the soil surface area is tilled in the seed line where cotton is planted. Strip tillage has been used with growing success in many California silage cornfields during the past 15 years. Cover crops that are not disked into the soil, but that are left on the soil surface as a mulch, not only do they help cool the soil, but they also have been shown to be highly effective at reducing soil water evaporation by as much as 13%, or about the equivalent of 4 inches during a typical summer crop growing period. The first recorded farm evaluation of the soil health management practices in the form of reduced disturbance tillage, that is, no-till, strip tillage, and ridge-till planting systems, the integration of off-season cover crops, and the preservation of surface residues took place by Bob Prize of Borba Farms near Riverdale, California, in western Fresno County from 2001 through 2003. Results from this effort showed that comparable cotton lint yields to the use of standard tillage practices could be reached using strip tillage. However, as in the earlier university work, great care and attention to equipment adjustment at the time of planting was needed. There was then little additional progress made on these sorts of fully integrated soil health management systems in California cotton for the next decade or so, except for occasional efforts such as this strip-till planted wide bed cotton planting by Danny Ramos, who was then with the Morningstar Company near Firebaugh, California. During recent years, however, and beginning particularly in 2020 and 2021, through the efforts of the remarkable partnership between Bowles Farming in Los Banos, California, California Ag Solutions in Madera, the Institute for Regenerative Agriculture at Chico State University, and FiberShed, actual cotton brand buyer payments are being put into place to reward cotton farmers for implementing these types of full-blown soil health management systems for California cotton. With the dedicated attention that is now being paid to the importance of soil health and agricultural systems, as well as the very strong partnerships that have recently been formed between some quite formidable groups, the expansion and further rapid development of quite advanced soil health management systems for California cotton now seem to be inevitable in the very near future.